Hello everyone. Let us talk about the problem given in the quiz. Let us first review the example given in this material. So, one example was about the analysis of calcium ion. So it says 0.4367 grams of sample was dissolved in water, and then the calcium ion was separated from the rest of the sample because this sample here contains calcium together with other materials. So to analyze for calcium, you need to separate calcium from the rest of the materials present in the sample. So calcium ion is precipitated as calcium oxalate. The precipitate is washed, filtered, and dry, and the precipitate is weighed. This is now the calcium oxalate monohydrate precipitate. Take note, this is different from the mass of sample. Etong mass of sample, merong ibang material aside from calcium. So the calcium was precipitated as calcium oxalate. Itong precipitate is calcium oxalate. Okay, so these are the factors. Okay, so ito yung mass of calcium oxalate. Okay, so take note, this is the factor that was used to convert grams of calcium oxalate to mole of calcium oxalate. Next is the factor that converts a mole of calcium oxalate to mole of calcium ion. Okay. So it's 1:1. So your factor here is 1. And the third is from mole of calcium to gram of calcium. Okay? So first factor is conversion of this precipitate to mole of calcium oxalate. Next, this is the ratio of calcium ion in the calcium oxalate. And the third is from the mole of calcium ion converted to gram of calcium ion. Okay, so if I put them together, ito yung conversion from gram of calcium oxalate to mole, then mole of calcium per mole of calcium oxalate, then uh, calcium ion to grams of calcium, mole of calcium to grams of calcium. Now, if I write it this way, take note, there are terms that we can cancel out, and this one. So it will reduce to something like this, where this is uh, where 1 here is this factor, the ratio of the mole of calcium to mole of calcium oxalate. Take note, 1:1 yan kasi isang lang ang calcium sa calcium oxalate. In other formulas, pwedeng dalawa, tatlo, etc. So you have here N. Take note, 40 over 146. So this is atomic weight of calcium, and this is molecular weight of calcium oxalate monohydrate. Kung magbibigay ako ng general formula, that will be N. This is the ratio of the material of interest, and present in the formula, atomic weight of the material of interest and the molecular weight of the compound. Let us again recall a similar presentation in this material. This is calculation of percent composition of each element in the formula. In the first case, this is C12H22O11, which is sucrose. Kinompute dito yung percent carbon, percent hydrogen, and percent oxygen. Okay, so take note sa carbon. Okay, take note of this. Okay, you have 12 kasi 12 units of carbon is present in the formula. C12H22O11. This is the atomic weight of carbon, and this is the molecular weight of sucrose, which is similar to this one. This N here is 12 kasi 12 siya sa formula. This is the atomic weight of carbon. This is the molecular weight of sucrose. So, ito rin yon. Ito rin yon. Yung gravimetric factor. Okay? And likewise, if you want to compute for hydrogen, ayan o ang gravimetric factor, and oxygen. Anong ibig sabihin yan? So, sa sucrose na C12H22O11, pag-usapan muna natin yung hydrogen factor. So, kung i-compute ko to, I will get 0.065. Ibig sabihin, if I have 100 grams of sucrose, I multiply it by 0.065, I will have 6.5 grams hydrogen. So sa 100 grams na sucrose, 6.5 grams dyan ay contributed by hydrogen. If you have 10 grams of sucrose, meron kang 0.65 grams na hydrogen. And if you have 0.2481 grams of sucrose, paano mo malalaman yung hydrogen? You have to use the gravimetric factor. So, using the gravimetric factor, you will have 0.016 grams of hydrogen. Okay, so gamitin natin yan sa ating problem. The problem that was given to you. A common example of gravimetric analysis is the determination of iron in an ore sample. Remember, an ore is a deposit in the Earth's crust containing one or more valuable minerals. So, hindi lang nag-iisa yung iron doon. Meron pa siyang ibang components. Okay, so this is the mass of the sample, which contains iron and other components dissolved in acid, and the iron is oxidized to plastricate and precipitated as hydrous oxide. So, ferric oxide X water. Okay. The precipitate is filtered, washed, and take note, merong step na ignition. Okay, so ignition is heating the material to a very, very high temperature, resulting to removal of water. So eventually, ang na-collect na mass, wala na tong water. Okay, tapos na siyang i-ignite, nawala na yung water, 0.2481. This is now pure ferric oxide. You are given the atomic weight of iron. You are given the atomic weight of ferric oxide. All you need to do is write the expression, calculate, translate it to weight of iron in the ignited precipitate, and eventually present iron in the sample. Okay, so balikan natin yung uh, uh, formula natin last time sa calcium at gayahin natin to para sa ferric oxide. So this time, yung iron sa ferric oxide, ilan? Dalawa. Kaya yung N mo dito will be 2. 2 times atomic weight of iron over molecular weight of ferric oxide. Pwede mong isulat na ganito, 2 times Fe over Fe2O3. Understood na yon na this one is atomic weight and the one at the bottom is molecular weight. So this is plugging in the values, given naman tong values na to, you will get 0.6994. Okay, so next is to find the weight of iron in the ignited precipitate. So what do you do? That is from number 2. You multiply this by the mass of the precipitate. Ito na yung pure ferric oxide. By this factor, you will get this. So ito na yung iron. The iron present in the precipitate. Yung sunod is what is the percent iron in the ore sample. So ito na yung iron over the mass of the ore, yung sample, yung mixture, times 100 will give you 35.76%. Remember, ito yung given sa inyo. 4 significant figures. And ito rin yung given sa inyo, 4 significant figures. Kaya yung final answer, since you carried out multiplication division, your final answer should also contain 4 significant figures.